All right, let's get into it. Today, we're basically going to build a house, or, well, the blueprint for one anyway. We are going to take a simple idea and walk through how to turn it into a real-world application using Python. You'll see exactly how all the pieces, from data all the way to databases, snap together. So, how does that actually happen? How do you go from a spark of an idea to a tool that someone can actually use? Well, to figure that out, we're going to follow the entire life of a little micro project, a simple inventory system for a local shop. This example is going to be our guide for seeing how Python really works out in the wild, step by step. Every builder needs a good set of tools, right? For us, that tool is Python. So let's kick things off by figuring out exactly why it's the perfect language for a project like our inventory system. Python's biggest advantage, honestly, is its sheer versatility. The syntax is so clean and readable that you get to spend your time solving problems, not fighting with a language. It's an absolute beast in data science. You've got libraries like Pandas and NumPy, but it's just as good for building websites or automating boring tasks. That's exactly why people call it the Swiss Army knife of programming. It just does so much, and it does it all really well. Okay, before we can build our shop, we need a blueprint for everything that's going to sit on the shelves. In the world of programming, that means we have to decide how we're going to store our data. And that's where Python's basic data types come into play. So, quick refresher. These are our fundamental building blocks. A product's name, that's a string. The number we have in stock, that's an integer. The price, with its decimal point, is a float, and whether it's in stock or not is a simple Boolean, true or false. And of course, a crucial skill here is typecasting. You know, when you get input from a user, it's usually a string. You'll have to convert that to an integer to do any math with it. These might seem basic, but they are the absolute foundation for everything else. Now, how we organize these data types is a huge deal. We could just throw everything into a list. And yeah, that's fine for just a simple sequence of product names. But to actually describe a single product with all its details, a dictionary is so much more powerful. It uses these key value pairs to give our data meaning. The name key points to iPhone, the price key points to $999.99. Choosing the right tool here is a massive architectural decision. Okay, our data has a structure. Now it's time to build the engine that makes our inventory system actually do something. This means writing logic to make decisions and creating functions to keep our code organized. Let's start with that core decision-making part first. Really, at the heart of any useful application is just making decisions. We do it with conditional logic. For our little shop, it could be a simple check. If an item's stock is greater than 0, then we let the sale go through. Else, we flash an out-of-stock message. This is how our app stops being static and starts reacting to the world around it. So having an app that works is one thing, but having one that's reliable is something else entirely. To make sure our code does what we expect and doesn't just fall over, we have to talk about a really crucial professional practice: testing. This is a really fundamental idea in software. The point of testing isn't to prove your code is perfect. You can't. It's basically impossible. What you're really doing is systematically hunting for errors and bugs before your users find them. It's all about quality control. So you can do this two ways. Traditionally, you write your code and then you write tests for it. But there's a more proactive way called test-driven development, or TDD. Now, this sounds a little backwards. You actually write a failing test first using something like Python's unit test module. Then, and only then, do you write the bare minimum code to make that test pass. It's a total mindset shift, but it forces you to build better, more testable code right from the get-go. This whole TDD workflow has a famous rhythm to it. Red, green, refactor. First, red. You write a test for a feature that doesn't even exist yet, and you watch it fail. That's a good thing. Then, green. You write the absolute simplest, most direct code you can to make that test pass. And finally, refactor. Once the test is green, you go back and clean up your code, make it more efficient, all while making sure that test stays green. It's a really powerful loop for building quality software. Okay, so our app has data structures, it has logic, and it's well tested. But we have a huge problem. Every single time we close the app, our inventory just vanishes into thin air. We need a permanent warehouse for our data. And that brings us to databases. To put it simply, a database is just a structured system for storing, managing, and getting data back out, and doing it all efficiently and safely. For our shop, it's the digital warehouse where we'll keep a permanent record of every single product, its price, its stock count, everything. And I know what you might be thinking. Why not just use a spreadsheet? For a super simple list, maybe, but for a real application, it just doesn't cut it. A database like SQLite, which works great with Python, is built to handle structured data, let multiple people use it at once, and run really complex searches. For an inventory system that you want to grow, a database isn't just a nice to have, it's absolutely essential. We talk to our database using a special language called SQL. And the very first thing we have to do is use the create command. This is what builds the table, which is just the digital version of the shelves in our warehouse. It defines the structure for our product data, kind of like how we designed our dictionary earlier. Once the shelves are built, it's time to stock them. That's what the insert command does. It adds a new product, a new record, into our table. Every single time a new item gets added to the shop's inventory, our application is going to run an insert command behind the scenes. But here's where the real magic happens. It's all about asking questions, and we do that with the select command. We can ask for one specific product, or we can ask complex questions like, show me all the items that cost less than $500 and have fewer than 10 left in stock. This is how we turn a pile of raw data into information we can actually use. So let's just step back for a second and look at the whole journey. We started with nothing but a simple idea for a shop, and we've ended up with a solid, data-driven blueprint for a real application. When you lay it all out, it's pretty cool. We started with just an idea and picked Python as our tool. We drew up the data blueprint using dictionaries. We built the engine with some simple conditional logic. We made sure it was reliable with test-driven development. And finally, we gave our data a permanent home in a database. See how each step builds on the last one? It's a complete logical path from a concept all the way to a creation. These ideas aren't just theoretical, you know? They are the real-world building blocks for pretty much any application you can think of. You've just walked through the entire blueprint for one. So the only question left is, what are you going to build next?